Hey friends, welcome back. In the last video we talked about matter, and in this video we're going to talk about the changes that matter undergoes. So stay with me. Let's go. Now, sometimes we can have matter that undergoes a change in appearance without altering the composition itself. Here's a sheet of aluminum foil, but I can also wad up the aluminum foil like so. I have greatly altered the appearance of the aluminum foil, but yet it's still aluminum foil. It has not changed its composition. This is an example of a physical change. Nothing in the way of the chemical composition has changed about this aluminum foil. The same can be said if I take a piece of paper and tear it into pieces. It's still just paper. It has not changed its chemical composition in any way. There are other types of physical changes like we see here. This is just a simple flask of water, and I put it on a hot plate. You can see that it's actually boiling. You can see the bubbles here. What we see coming out of the top is vapor, water vapor, the gaseous form of water. This is an example of a physical change as well. The water is not changing its composition. It's simply going from one state, the liquid state, to another state, the gaseous state. So, anytime you have a phase change, you have a physical change. Let me say that again one more time. Anytime you have a phase change, whether you're going from solid to liquid or liquid to gas, that is a physical change. So there are automatically some terms that we use when describing physical changes, like boiling or freezing or condensing, sublimating. These are all examples of phase changes and therefore physical changes. Now those temperature and pressure changes that accompany a phase change are actually pretty important physical properties for a particular substance. We know that water boils at 100 degrees Celsius or it freezes at 0 degrees Celsius. Those physical properties are part of water's identity. Now, sometimes we have changes that involve a substance turning into a different substance. That is when we have a chemical change. Take, for example, when I add vinegar to this baking soda. We can see that there's a chemical reaction taking place, the fizzing that takes place of this mixture. What is happening is we are forming two new substances. We have vinegar to begin with and baking soda to begin with, but then two new substances form from that reaction. The two new substances have different chemical properties than the substances we had to begin with. Here's another one. Iron combines with oxygen in the air and undergoes a chemical change and forms rust. We call it iron oxide. So that's an example of a chemical change. It's also a chemical property of iron. Iron combines with oxygen to do just that. Now, whenever we have a chemical reaction, the things that we start with are called reactants. What comes out of the reaction are called products. Sometimes particular words can clue us into the fact that a chemical reaction has occurred. Words like decompose, or explode, or corrode, or rust, oxidize, tarnish, or even burn. These are all examples of chemical reactions. And as we've seen from reactions like the one with baking soda and vinegar, sometimes we can see evidence of a chemical reaction right away. We might notice fizzing or burning or even a color change. Different types of chemical reactions. In the late 1800s, scientists were finally able to start really taking a closer look at chemical reactions. Part of this was because around that time the analytical balance was developed, and this enabled scientists to get a closer look at the masses before and after reactions. One of those scientists, a French scientist named Antoine Lavoisier, was able to determine that in a chemical reaction, the mass of the reactants, the things you start with, was actually equal to the mass of the products, the things you end up with. This idea led to what we call the law of conservation of mass, that in a reaction, in a chemical reaction, mass is neither created nor destroyed. It is conserved. Lavoisier was able to prove this by using an analytical balance to monitor a reaction in a closed tube of mercury oxide as it decomposed. As it's heated, mercury oxide breaks down to form mercury metal and oxygen gas. In this closed tube, nothing was able to get out, the oxygen was not able to escape, and the analytical balance showed that the mass before and after was the same, thus giving evidence of the truth of the law of conservation of mass. Now folks, you need to understand, this law is one of the most fundamental concepts in chemistry. A proper working knowledge of this law is going to help us when we talk about things like balancing chemical equations, forming reactions in general, stoichiometry, which is something we'll get to later on. In all of that, we have to have an understanding of the law of conservation of mass. Here's a very simple example of using the law of conservation of mass. Let's say that we have this reaction where mercury oxide is heated and decomposes to form mercury metal and oxygen gas. Now if we start off with 10.00 grams of mercury oxide, and after the reaction we have 9.26 grams of mercury metal, how much oxygen gas do we have? What's your answer? The answer is 0.74 grams of oxygen gas. How do we know? Because of the law of conservation of mass. Remember, both sides must be equal. So if we have 10 grams on that side, we have to have 10 grams on this side. So 10 minus 9.26 gives us 0.74 grams. And that's how much oxygen gas we'll have in this reaction. Here's a quick and hopefully easy little homework assignment for you, using the law of conservation of mass. Here we go. In the reaction of sodium and chlorine to form sodium chloride, let's say that we start off with 22.99 grams of sodium and 35.45 grams of chlorine. The question is, how much sodium chloride will we have? That's all the time we're going to take for today, guys. We started off by talking about physical changes, including a discussion of phase changes, going from solid to liquid or liquid to gas, and how a phase change was a type of physical change. And then we talked about chemical changes, how in a chemical change you have a complete change in the composition of the substances that you're putting together, going from one substance to another. Then we finished our time by talking about the law of conservation of mass, how important it's going to be for us to understand this law, especially when it comes to chemistry later on. So I hope today's been beneficial for you. If you have any questions or need a little help understanding something, please don't hesitate to let me know. Until next time, God bless.